Hello. In this video, I will be walking through the Disclosure Review Notebook. This presentation will follow in a very similar fashion to the presentations that we did in class during Module 2, except in this case, we're going to just be transferring them to a video so that you can review them whenever you would like and go back to them, if you have any questions or forgot something that was discussed in the notebooks. But this will follow very similarly to how these notebooks were presented in the class. So just as an overview for this presentation, we'll cover 6 main topics. So first, what are the main R packages and functions that are used in this notebook? 2, just some general remarks on the disclosure review process. 3, creating fuzzy percentiles. 4, exporting visualizations. 5, working with percentages. And 6, and finally, just some general rules of thumb when it comes to exporting. So for the main R packages and functions used in this notebook, in terms of the packages will remain the same as they were in, let's say, like the data exploration notebook. The survey package is used a little bit because 2 of the examples work with SDR data, which is a survey. So we need to be able to apply survey weights to the data that is in the SDR. So there are 2 different functions within this survey package that we have used in the past and that we use in this notebook to set the examples to prepare the examples for disclosure review. And those 2 functions are SVY design, which enables you to add weights to a data frame, and SVY quantile, which allows you to find weighted percentiles to sort of mirror a distribution. Other functions that you may have that we have not included in any notebooks, I believe, up to this point, but are quite essential when it comes to preparing files for export are write_CSV, which enables you to write a data frame that you have in R to a CSV file, and ggSave, which enables you to save visualizations built with ggplot as PDFs. So just some general remarks on the disclosure review process. There are specific types of files that we prefer for export. Some of those are CSVs and .txt files, especially like when you're exporting some sort of data frame. And for graphs, we prefer PDFs or PNGs. If you have any questions about that, feel free to ask your facilitator. They will be the one who's actually in charge of submitting the export for review. So they should be able to answer any questions you have about the export process. When the export reviewers are reviewing your exports, it's very helpful if you clearly document your code. Also, just in general, this helps for reproducibility, or if you're sharing results with a team member, just to explain exactly what the code is doing. But if you could clearly comment what each specific piece of or each specific code cell is doing, that would be very helpful for the reviewers as they go back through your work that contributed to the export request. And second, in terms of documentation of code, we prefer, as a reviewers, we prefer clear variable names. So if, let's say, in the data frame that you are exporting, instead of calling the counts of individuals var1, if you could change that to counts individuals, so it's very clear and it indicates to the reviewers that that variable corresponds to the counts of individuals. Now, for each statistic for export, while you may, in case of the SDR, when you're working with weighted data, you of course want to export the weighted results, but you must also show the underlying unweighted counts. We need those to understand exactly what was in the original survey data. So in your input folder, you would include, and this would constitute as that supplemental data. It's covered how to actually calculate the unweighted counts based off of weighted data from the SDR. Each count should be above a specified disclosure threshold, otherwise it will be suppressed. In this case, the disclosure threshold is at least 10 individuals per group, and at least 3 institutions per group. Otherwise, it will be suppressed. You must show these results as well that correspond to your desired export. Again, if you have any questions, you can refer back to the specific notebook, or you can ask your group facilitator and they will be able to help you. And finally, just in terms of our disclosure review process here at the Coleridge Initiative, we prefer you only to export results when they are final, as this decreases the risk of re-identification. So then we go into, in the notebook, how to calculate fuzzy percentiles. And first, there has to be a reason to calculate fuzzy percentiles. So just as a general disclosure or an export rule, individual percentiles cannot be exported, or exact percentiles cannot be exported. So for instance, you could not export and say the 25th percentile of within this group was 100 or was 150, and you weren't, and of course the median is the 50th percentile, so that could not be exported directly either. Luckily, there is a solution, and that's to make these percentiles fuzzy, if you will. So effectively, for instance, if you were to fuzzy a 25th percentile, you would take the average of the true 20th and 30th percentiles and report that as the fuzzy 25th percentile. And the same thing goes for the median. In terms of the actual code, what that looks like, in this example, we are showing how to create fuzzy percentiles for the weighted, as we covered before, SDR data and their weighted salaries. And so we save what the true percentiles were. So we calculate the true 20th, true 30th, true 45th, and true 50th percentiles. And then from there, we can create the fuzzy 25th and fuzzy medians. So then we shift gears a bit and move towards visualizations. So each graph must have a corresponding underlying table that contains the counts of the individuals as well as the institutions per group. So an example of this is the code right below. So if you see DF and it's piped into the right CSV where you have your file path, and then this would be, let's say, like the individual counts for this histogram of salaries, or the institution counts for histogram salaries. It helps us a lot if you actually name these CSVs as well, so it's easy for the reviewers to tell which supplemental files correspond to which files you would like to receive for export. And so as we talked about in the first slide, just as a reminder, in terms of saving graphs built in ggplot, you can save those using ggsave. Ggsave will save the most recent visualization you have run using ggplot. And it works in the same way as write-csv, where you determine where you include the path, and then the final slash would be what you prefer to call the visualization, and then .pdf, so it saves as a PDF. So in this case, you would be saving a file as histogram_salary.pdf. So for histogram and bar plots in particular, when we are referring to groupings, we are referring to the specific bins or bars in this case. With histograms, it might not seem as intuitive, but you have to view each single bar or bin as a specific grouping in this case. And we need to make sure that each one of those bins or bars passes the disclosure review. So as a threshold, as a reminder, that's 10 individuals and at least 10 individuals and at least 3 institutions. If you run into a case and one of the examples in the disclosure review notebook shows a bar that will not pass, ordinarily pass disclosure review because it has either or both too few number of individuals or too few number of institutions. You can aggregate certain bars or bins to expand those categories, or another solution is just to cut off assuming that it's on the end, or just not include a specific bar or bin and just acknowledge that it has been redacted for disclosure review purposes. So in terms of our final example, it discusses working with percentages. Now percentages, there's sort of like an extra layer that you need to include, because a percentage, just as a review, is calculated by doing the numerator dividing the numerator by the denominator, multiplying that by 100. So we need both the counts for the numerators and the denominators of both the individuals and number of institutions to pass our disclosure review. And you must indicate this in the underlying CSVs that would correspond to a visualization of percentages. And if you were working with, if you were exporting numerically just some percentages as opposed to like visually some percentages, or graphically some percentages, if you were to do this numerically, then you would just need to provide the individual counts within the numerator and denominator, as well as the institution counts for the numerator and denominator. These percentages, proportions, and ratios can be calculated using the unweighted counts, and then and these percentages must be rounded to 1 decimal place. Finally, please do not report 0 or 100% within a specific grouping. So finally, and just to close this out, in terms of the rules of thumb for a disclosure review, so if it will greatly help, and it will actually probably speed up the review, as well as it'll make it much easier on the reviewers if you clearly document your code and use variable names that correspond to the information within those variables. So as we discussed earlier, instead of calling a column var1, if you called it individual counts, it would be pretty clear and indicate to the reviewers very quickly that that variable, it corresponds to the counts of individuals. For each statistic for export, you should make sure that you're showing all necessary underlying counts. So this is going to be the counts of the number of individuals and institutions per group. For each graph, you must also show the underlying table or tables, depending on how you prefer to actually create those underlying tables. And these underlying tables will also just be counts of individuals and institutions. And then finally, only plan to export results when they are final.